So in this lesson, we are going to look at something called Process Explorer from sysinternals. Again, we are going to focus on our application, the client and server from Process Explorer. It's another tool which is very similar to Task Manager in Windows. If you are into Linux, Process Explorer is a combination of lsoff command and top, if you will, but it has some more information into it. Now let's download the tool and focus on our application, our client and server, the network socket applications we have developed. So to download Process Explorer, just like we did for the other tools, go to Google and type Process Explorer. So Process Explorer from sysinternals, that's a better searching keyword. You should see a link like this and you can download just like this. So I'm going to unzip it here itself and right click run as administrator. So again, while we are running Process Explorer like this, we need to make sure that our application is in the same state as this. We have not changed the state of the application. So this is important, otherwise you will be seeing different results. So you have restarted your application, your server client, anything, you need to get it to this particular state. The reason I have not restarted the client or server is because we are maintaining the exact same process ID. So it is easy for us to hunt these Python processes easily. We already know their process IDs. We have so many different Python processes because of Visual Studio Code. If you want, you can run these programs from command line and avoid all these processes. So like I mentioned, Process Explorer is nothing but Task Manager on steroids. It's an advanced task manager, very useful tool when it comes to troubleshooting problems. So these are different programs running in the system right now, and our Python application is one of them. Always go for the child ones. So in this case, as you can see here, when I hover the mouse, I can see listen server in the end. So this should be our server because we are passing listen server.py into it. We can check the process ID as well. The process ID is right here, 20260. That is the process ID. If you remember, there is the same process ID in previous experiments as well. We have not changed it yet. Now don't worry about all these other Pythons running here. They are by Visual Studio Code. So they may look similar, but they are not the actual Python which we are interested in. Now let's try to find out our client. So again, if you see this tree structure, go for the innermost one. In this case, it is this particular process, and we are passing network underscore client.py into it, as you can see here in the command line arguments. So if you're confused about what is command line argument and all those kind of details we are seeing right here, I recommend my previous Python training or any other Python training which explains all this details. In fact, I really recommend that training if you're new to anything you are seeing right now in the screen. Otherwise, all these should be familiar to you. Now, being said that, let's check the process ID 13976. So that was the process ID of our client. Now what we are interested is the server. Let's look at the server, what we are going to see. So for the server, we have handles, DLLs, and threads. Pretty much we are looking inside the process from outside the process. So the debugger right here. So this is the debugger of the server. This is looking into the process from within the process. We can see the code, we can see the variables and all that kind of things. Now we are having an outside perspective. Process Explorer has nothing to do with our application. It is a very generic tool. We are spying on our application using Process Explorer. In fact, all the tools we've been using so far is all kind of looking from outside. Here also, we are looking from outside, but in this case, with much more detail. So we can see so many handles. loaded into the process. So many open handles. In our case, we are specifically interested in one particular object, a file object called AFD/device AFD. So we'll come to it, what this really means. It is called ancillary function driver in Windows. It is a very Windows specific term. So this driver is implemented by a file called afd.sys in Windows. afd.sys. It's one of the most important system files in Windows. So this is the ancillary function driver for WinSock, if you look at. So we will get into these details again in future. I know I'm repeating this one particular thing a lot, but unfortunately I have to, because a lot of these details I cannot give you right now because we are still yet to explain a lot of things like network stacks, TCP/IP, a lot of such details. But for the time being, we are going to learn that there is this object, file object in Process Explorer called AFD, and that file object is implemented using a driver which is there in the kernel of Windows. This laptop has this afd.sys, which is making this particular device object. Now, if you carefully look, this is a file object. Why file? Why it is not a network object or a socket object or something other than file? We have not even dealing with file. So if you look at our program, this program, there is no file business here. Then how file object has created? We are doing socket programming. Why it has created a file? Now you might be thinking that, okay, this guy is making up things. What is the relation between this AFD and my program? I don't see any relation. Why would you trust me? You should ask this kind of questions all the time. You should not trust me in anything. I could be simply making things up. So let's see what is the connection. So what we are going to do is we are going to let the client go and break into the next statement of the server. After long term, we are going to execute one more line so that we will get this breakpoint in line number 10. I'll tell you why we are doing this. So what we are going to do, we are going to let the client go. The client is waiting on line number 9. The line number 9 is not executed yet. So we are going to do that. So I'm going to press F10. And as soon as the F10 is executed, the server is broken back into the debugger. Now we have this object right here in the Python. So this is fully Python. There is no Process Explorer business here. Now let's pay attention. So we have something called socket here, if you look carefully. So let me copy this from here. So I have copied that to a notepad just for easy to view things. So we'll get into these bits later. Some of the things we had a quick look, but not in detail. What we are interested is this number 1012. So what is the socket we are talking here? 1012. So we are talking about our listen socket, which has a variable name yes. In this case, it is the listen socket. We have one more socket or one more object here with a different FD 972. So let's note that as well. 972. I'm just writing that number down here. 972, another FD. By the way, this FD is not the FD in AFD. Don't get confused, although you will see a correlation just now, but this FD is different. I think this FD simply means file descriptor, nothing else. It doesn't matter to us. We don't care about what this really means. Some programmer written something somewhere. It doesn't matter to us. We are not even dealing with Python here. We are interested in this particular number, which is important to the kernel of this laptop right now. Now, let's go back to Process Explorer. So we are seeing these numbers right here called handle. We don't know that yet. We may never know or never get into the details of it as well. All we are trying to build is a correlation between our Python application and these file objects right here, AFD. I made a statement that the they are related, but I have not given you any reason behind it. That's what we are trying to do, build a relationship. Now, these numbers are in hex. The number we got here, these numbers from our Python application doesn't look to be hex. You don't see any ABCD in this. So we need to translate these numbers to hexadecimal. Right now these numbers are in decimal. We need to convert this into hexadecimal or 16 based numerals. So let's do that. We'll be using a calculator for it. So let's go ahead and start a calc application. In the calc, you can select programmer. There are different options here. Programmer. There are so many ways you can do decimal to hexadecimal translation. If you don't know what all these things, bin, oct, hex, I recommend some of my previous trainings. We don't have, unfortunately, time to get into the details of it because we have a lot of networking specific things to discuss. So in this case, what I'm going to do is I'm going to convert this number 3F4. That is a hexadecimal I got. So let's go back to Process Explorer and look if there is anything similar to it. Is there? As you can see, we have a 3F4 is there. Is that a coincidence? Absolutely no. Let's try the other one. 972. Again, I'm copy pasting here. We have 3CC, the hexadecimal, equivalent to 972. Let's see if there is anything here. And we have 3CC. We have two more other guys which we don't know. In fact, we don't care. If you're curious, it is because of the debugging we are doing using Visual Studio Code. But these are the two numbers we are interested in. Again, remember, we are looking at these things like a detective. We are not trying to understand everything. We are collecting different types of information about this two, server and client, slowly building up our story. We are trying to find out what is going on. That's the thing we are doing. We are finding out different clues and hints from different tools and spying the application from different angles. We found out an interesting thing right now, a completely unrelated tool which is showing a file object, and that is coming up in our Python application right here. That's a very interesting correlation. What Python has to do with Process Explorer. So we'll get into it, but just remember this guy, AFD. We will discuss about it. And these handles which is coming up, these file handles right here. Now this is again the server. We'll look at client shortly and we'll make sure that client also has something like this. Before that, let's have a quick look at the threads of these application. Now, before looking at the thread, one thing we need to do in Process Explorer is something called configure symbols. So in my Process Explorer, I have already done that. What I will be doing if you're doing this demo by yourself. In fact, I don't recommend doing all this demo by yourself because these demos are very, very detailed, not very useful in your daily life unless you are really digging your network stack. So these demos I'm giving you to understand things. Normally, you will never look into your AFD sys in a Windows. I hope you don't have unless you are developing a device driver or something like that. But in case you are doing this demo, I will be providing you this particular DLL because otherwise you have to install Windows kits and debuggers and all sorts of things. So I'll be providing you this DLL and you need to give the path of the DLL right here in configure symbols. So remember to do this, otherwise you will see a different result than what I'm going to see. Again, copy and paste this thing. Just type this exactly as it is. This is MSDL. Rest looks straightforward, but this is MSDL. srv*/msdl.microsoft.com/download/symbols. That is the symbol path you need. And this DL I'll be providing you, you need to give that path in case if you're doing this demo by yourself. You don't have to do this demo as I mentioned. I'm clicking OK here because I have everything in place. Now, to see the thread stack, you need to have the symbols right. What we are going to do is we are going to look at different thread stack. So in this case, we don't have much of an interesting stack right here. We will see a different stack in process monitor in the next presentation. But what I wanted to show you is if the application is listening on an accept, you will see that accept here. So what we can do is we can come back to this after restarting the server after looking at the client. So what we're going to do next is going to look at the client and the handles of the client and make sure that we're going to see that AFD thingy. So this is our client 13976, and if you're going to our file object, we have the AFD thingy here. So let me sort it with the name so that we'll see all the AFDs. So we have 3 AFD, and let's go to our client application. So this is a client. In this case, we have only one socket, which is the S, and the FD of that is 864. I need to clear it up. 864. So the hex is 360. Let's see that. As you can see, 360 is right here. So this is a file object which is sending IO to the kernel and helping the client to connect to the TCP stack. So that is the purpose of AFD. We will see that. But this is a file object Python has created when it created a socket. All those details is for another time. Again, we have the thread. We will see that when it is waiting. What we are going to do next is we are going to restart. After a long time, we are going to restart our server. So the server will go and listen at this particular line number 7. Now, what we're going to do is we are going to look at Process Explorer. So let's make sure that it is the server. As you can see, the process ID of the server has changed. 22064. That has been changed. We need to restart the client as well, but for the time being, we are going to look at the server. Now, if you look at the threads of the server, you can see a sock async thread is right here from MS WinSockDL. This is connected to the socket action which is happening inside the process. We'll see a better stack inside Process Monitor, which is the next tool we are going to look at to dig further into these applications. But for the time being, you can see some signs of things which is happening inside the process. If you double click on it, you will see a IO completion port waiting. Not much important to us. We can't see the stack correctly because it is an asynchronous IO which is going to the kernel. We might have got a slightly better stack if the process was 64-bit, but in this case it is 32-bit. So what I'm going to do is to see if we can see a better stack, I'm going to change the Python. Let me stop this and change the Python to a 64-bit version. So right now the Python is 64-bit, and coming back to the Process Explorer. Now I'm going to double click on this python.exe in the thread tab. If you're doing it for the first time, you may see a little bit of delay because the symbols which we configured must be downloading. As you can see, Python is calling into the system right here. So this is something called call stack. If you're new to call stack, again, I recommend my previous training. Basically, this function calls, this function calls, this function calls, this right here. This is where things gets interesting in terms of system calls. So this is the WinSock accept. So this is a documented Windows API, WinSock API. In fact, Python is calling into the Windows socket layer right here in frame number 16. And then on, it is going with WSA accept. So these calls are documented. So if you go to Google again, WSA accept, we'll get the documentation of it. So it'll have very similar syntax as the Python. Basically, under the hood, Python is just calling this C++ function to get into the Windows kernel. We'll see much more detail in Process Explorer, which is the next tool we are going to dig. So a couple of things to notice here is configure your symbols before you dig this part of the things. and make sure that your process is doing the right thing. Because right now this is waiting on this accept. If it is doing something else, you will not see what I saw. And make sure that you have 64-bit. Previously I had 32-bit. You can look at 32-bit stack in a different way. I have a whole big complicated training on WinDebug on that. But for the time being, just use the 64-bit like I'm doing right here. So it is waiting on the accept, and this accept is calling wc accept on a file object and getting into the kernel. You can find similar stack inside client if you like, but we are going to see these things in detail in process monitor. Don't get confused. We are looking at process explorer right now. Next tool we are going to do is process monitor. Process monitor will give you all this kind of stack in much more detail. So I'm not spending much time to give you that redundant information. So that's all I wanted to show you in Process Explorer. And as I mentioned, we will look at our next tool, which is Process Monitor. So to conclude, we have looked at Process Explorer from sysinternals and looked into our application. Now, there is another very similar tool. In fact, the name is very similar, Process Monitor. What we have seen is Process Explorer. In Process Monitor, we see a lot more information about our application, the client and server. It's again another tool from sysinternals. In Linux, it is similar to strace or ftrace, basically logging the function calls. So next, we are going to look at Process Monitor.